Yes, Vamsi, we
Yes,
can
yeah,
see that.
we can see the screen.
Okay. Okay, let's go to the query. And now it took 4 minutes 26 seconds for its completion. Okay, so what should we do to speed up this query? So that is our main goal. So it is suggesting to create one index. So let's try to create the missing index what our SQL server has suggested. Okay, is this clear? First of all, so first I wrote a query, and that is taking 4 minutes 26 seconds for its completion. So we as a DBA need to fine tune this query. So for that, I am doing index tuning. So as part of index tuning, I'm trying to create a non-clustered index as suggested by our execution plan. Okay. So right now we are on 2012 compatibility level, just for your information. And so this is the execution plan, what I got. So forget about execution plan. We will talk about that later. So let's try to create the missing index suggestion that is given by SQL Server. So this is the suggestion. So let's try to create the same thing. Ix underscore, I'll say test for the moment. Okay, so I'm doing that now. So it may take time, like 2 minutes or 3 minutes. So I asked this question many a times. I'm asking this again. So if I am creating this index in real time and I'd like to know the progress of it, so what is the mechanism? So on your backheads, your CEO, your manager is asking for the progress. They want to know the progress of this index. How to fetch that information? This is the fourth class what I'm taking in this month, and each in each one of the class we discussed about this point, like how to get the progress of the index creation. Anyone knows?
It's statistics profile on.
Yeah, profile on. So we have to set statistics profile on, and then we need to run one query which I've shared multiple times, so I don't want to do that again. So let's wait for this index to get created, because I want to show without index it takes longer time. As you are clearly seen, it took 4 minutes 26 seconds. So once, let's wait for this index to get created, and once that is done, and let's see how the query execution gets progressed. Just because these are big demos, guys, this is 50 GB, so it will take time. Okay, so yeah, have to be little have some patience. So in the meanwhile, we can discuss something. Okay. Um, so if you see here in the cluster index scan, okay, so only 4 rows. Let me mute the guys. Guys, if you're not talking, please mute yourself. Okay, if you see here in the execution plan, the number of rows, what we need is just 4 rows, right? As you can see. So, I mean, here in the execution plan, if I go to the execution plan, the actual number of rows and estimated number of rows, if you just keep over there. Okay, so let it get completed. Otherwise, it may confuse you. You can see the image, right? Actual number of rows and estimated number of rows. Actual number of rows for all executions, I mean to say.
Yes, Vamsi. So there is a huge difference between the row count between these two.
Yeah, 4 is the actual number of rows for all executions, and the estimated number of rows for all executions is 739714, means 7.3 or whatever it is, some bigger number, right? So do you think
Yes.
it's a problem with statistics out of date, or what's your opinion on that? What's your take on that?
Stats out of date, I would say.
Okay, so in general, our consideration is we always tend to go with stats as the problem. And even for your interviews, you will always, I've seen many people saying the same thing, index. So when I ask about performance stuff, so they will come back with the answers like outdated stats. So he will update the stats and everything will get sorted out. So now let's see when the stats were updated and whether they are in place or not. So stats stats for users table. Okay, so it's updated long time back. Does it mean this is a problem, or what's your take on this? Will you just check this, or what is the other mechanism that you will say, okay, my stats are good, no need to do anything? In real time, usually we will go with SP auto stats and see how it when they got last updated. But there is one more thing that you have to consider. Okay, let me show you that part.
I think we need to
Sure.
consider the row count and the modification change
Yeah,
metrics.
yeah. There are many things. Thanks
Okay.
for your input. Who is this? Someone said row count and all.
Yeah, this
Your
is
good name?
Naveen Vamsi. Yeah,
Naveen.
this is
Naveen.
Naveen. Yeah, so this is
Yeah.
my first class. So last
Okay.
couple of weeks only I joined here.
Okay.
Thank you.
Yeah. So as Naveen said, you have to check few other things. So there are few DMVs that are available for you to cross check this, but I am not going into that. I'm just going with the basic commands. If you see your rows and rows sampled are one at the same, you need not worry about when your stats were last updated. Just an interview question and also for your performance tip. Just consider this as a tip. Of course, in real time, our stats will be up to date because we are doing either full scan or sampling. That's a different story. I'm just letting you know if your rows and rows sampled are one at the same, forget about your stats last updated date. It doesn't matter. When you see rows and rows sampled are same, that means your stats are up to date. Don't consider the date in this scenario. When you see rows and rows sampled, this means that my stats were updated with full scan. Okay, if it is done with full scan, you need not worry about your dates. That is the fundamental thing that you have to remember. Any questions on this DBCC show statistics and SP autostats? Because if you run SP autostats, it will give you the information with respect to indexes, because we have statistics on indexes as well as columns. Okay, there will be columns associated when you write any where class predicates. Say, for example, select star from table name, where some column name equal to some value. If I write that query, automatically SQL Server would create the column stats on it. So these are all column stats. So if you ask me what is this, this is the um, uh, table object ID, object name, and this is the column name. I mean, these are the column names and these are the object ID. If you convert this, you will get the same thing. Okay, so when you move on to the stats, the first thing what you have to check is when the stats were last updated. That you can find with SP Autostats. And if you want further information, you can cross check with show statistics. And if you see rows and rows sampled are same, that means our stats are done with full scan. Full scan. So just an interview question. If indexes were rebuilt, okay, if indexes were rebuilt, will it perform update of statistics? Will it carry stats update?
Generally, after
I,
building
it
after
won't.
doing a rebuild, it will drop the indexes and it will create the indexes of rebuild operation.
Just one more interview tip. If you are appearing for interviews, because I've seen so many people asking the same question, that's the reason I'm discussing. Otherwise, I won't. If you see, if you perform index rebuild, it will automatically update your stats. What stats? Because there are two types of stats, as we have just seen. One is index stats. This is index stats, and these are column level statistics. So when you perform index rebuild will never update any column level statistics. It carries out only for index stats. And also one more important thing, this is also an interview question. If you are performing index rebuild, it will update your statistics with full scan, not with any sampling. So how can I find whether I'm enabling, how can I find whether I'm doing full stats or sampling of statistics? As I told you, if rows and row sampled are same, it means my statistics are done with full scan. So that is the important thing that you have to remember. So here we don't have any problem with statistics. I just wanted to prove that, and I've just shared some interview questions. So I'm removing this. I don't need this window. Any questions with this? Only few questions. Um, Okay, so I'm removing. So coming back to this, so we just created the index. Okay, so we just created the index, and now we are running the same query. Previously, it took 4 minutes 26 seconds, and let's run this query. So it is instantaneous, right? At the very next moment, it is instantaneous. So do you think our index tuning worked here? It helped here? Obviously, right? So it was taking 4 minutes 26 seconds, and we are down to just 1 second. So what is the index that we have created? And this missing index helped us to create the right index in this scenario, right? So let's try to change the compatibility level and see how it behaves. Before that, I would like to show you one more important thing. So from where I got this value of, yeah.
Vamsi, I request, after you running the query, you have found one message, right? That we want to create non-cluster index key. So could you please show me that, like, where we have to missing
Yeah,
indexes?
I just grabbed this from missing index DMV. So once I executed this query from the execution plan, it suggested me to create the non-cluster index on this post table.
Okay. So
So
from there, we have
yeah.
picked it up and we are having, okay.
So no, for this query, it helped me. So I'm not saying blindly to follow this missing index DME, because if you watch my previous 3 classes, they were completely different. So I told not to trust this completely. But if you don't know anything about index tuning, try to create this as the some kind of base and try to see if that helps. Okay, so I'm not recommending. I'm just trying to ask you, if you are not familiar with your data and if you're not good at index tuning, maybe you can start this as a starting point. Just consider this as a starting point.
Okay.
So okay, it went fine. So let's try to change the compatibility level for a second.
And I'm sorry to interrupt you. And
Yeah, no problem. Go ahead.
yeah, and could you please explain how to analyze the physical operators, logical operators by keeping the table?
That is a big thing. So we will come over there. So
Okay.
just to show you up. So from where I got this number 739714 for post table. So it is saying 73974, like the estimated number of rows, right?
Yes,
If
yeah.
you can see. So from where I got this number and how it came into picture. It is guessing some rows, right? So from where it is fetching that information.
Based on CPU, memory, and all those things.
From histogram.
Yeah, from the cardinality estimator.
So Meswin said it is from histogram. Yes. So if you run DBCC, of course I removed that window. Let me run it again. DBCC show statistics. This is from histogram, guys. Very, very, very important thing is histogram. If you understand the histogram and density vector, most of your problems can be avoided. Most of your problems, but no one will focus on the 2 things, histogram and density vector. I don't know why. Okay, so let's go with, what is that table in execution plan? Users, right? Okay. Users. Okay, and what is that index? PK underscore users underscore ID. PK underscore users underscore ID. Okay, this is the histogram, guys. This is the histogram. If you see here, what is the query it is considering on? So it is saying predicate. Just look at the predicate class. Okay. In the predicate class, I am asking for users reputation. As you can see, users dot reputation plus users dot views. Okay. So this is kind of a sum function. We are writing a sum function here. A plus B. A plus B is nothing but sum. So we are summing up the columns of reputation and views. Okay, so from where I got that 739714. So if you check out my what is this sorry, statistics inside the histogram, I have the information only with the leading column. What is that column on which I have the information associated with statistics? If I just move this up, it is on PK underscore users underscore ID, which is the primary key. ID column. So this is the column on which I have the information. But we are asking about reputation and views. I don't have any information with reputation and views. So from where SQL Server got that 739714 value? That is what you should understand. Okay. So we are getting that number from here. Okay. I will show you from where it is getting that. Just give me a second. So this number, if I divided this number with the number of rows inside the table from the users table, I'm going to get some value. Okay. Focus on that value. So it is 30%. So this is 30 point something. Okay. Just for your information, guys, if you have anything like this, some function or any other functions inside your where class, okay, especially these kind when you're joining multiple columns together. I'm not saying talking about inner join, I'm talking about the where predicate. When you are saying column plus some other thing or some functions, date, div, something like that. So statistics will come up with a certain formula. Okay, that formula here is 30% of your table. 30% of your table. That is the reason we got this number. 30%. So if you do, let me show you mathematically. So what is that count per count of star? So we have these many rows. Okay. So what is 30% of this number? So if I go over here and go to my calculator, so this is my number and 30%. I don't know how to calculate 30%. So I'm doing 30 and divided by 100. Okay. If you see exactly, we are coming up with the same number, 739714. If I round this up, it is 739714. So this is where SQL Server is fetching the information. Okay, for each and every row's information, what you are getting, there is certain formula associated. It will not fetch the information blindly. Okay, you need to understand from how it is getting that information. So I'm just showing an example, but in real time, this is not going to be that easy. And there are high chances for you to misinterpret this information as well. So I'm just letting you know where SQL Server got this information of 7,39,714. Okay, any questions? So there is a formula. There is a formula. If you see greater than, less than, also I'm letting you know, guys. If you see where start date greater than, end date less than or equal to, greater than or equal to, in all those cases, this formula is applicable. It is 30% of your table. Blindly 30%. This is the algorithm behind the SQL Server statistics. Okay, so that's the reason we are getting 73,900, sorry, 7,39,714. You got this number, right? Understood from where you got this number? Is that clear or confusion?
Clear.
Yeah, thank you, guys. If you don't talk, I will be literally confused. Okay, now I'm changing this to 2022 compatibility level. Okay, it went fine. So let's try to run this query again and run this. So we are again getting the results in within a second. Okay, and all of a sudden, the execution plan itself got changed. As you can notice, you can see this, right? Previously, we had something else, and now the execution plan itself got changed. Okay, and why do you think the execution plan got changed? And is there anything that is helping the SQL Server to go with this execution plan? Because each and every compatibility level, you will see different execution plans. There are few reasons for it. So if I start explaining that, it will be very hard, very deep. We need to go very deep level. So I will show you about that, not now, but in my upcoming classes. But if you see, there is a lot of difference between the execution plan. Let me switch that to 2012 again. Remember this execution plan, guys. Okay, I will take a snap. Snapping. And see the watch out for the differences in the execution plan. Have you seen something over the top in the actual execution mode by name batch? The third
Yes,
one
Vamsi.
is,
Yes.
yeah, just keep a note on it. Just keep a note. So let me switch this to 2012 again. 2012. Okay, it is done. Let's run this query again. Okay, so the query was taking just 1 second, not even 1 second. It's just a fraction of a second. And now after changing to 2012, this is taking longer time, 14, 15, it's going, okay, 16 seconds, 17 seconds it took. Okay, so why 17 seconds? I will let you know about that part. And if you see the execution plan, let's minimize this for a second and let's compare this. You see the select, top, parallelism, and here we got sort, and here in 2022 compatibility level we got hash match. Okay, and here we didn't get hash match, it went for nested loops. We will analyze why we are getting this part, but this is very complicated, so I don't want to dive in my first class right now. So I will show you the importance of the operators later. Okay, someone asked me how to do that. Definitely I will do that, but not now. Okay, the execution plan itself got changed. That is first thing. Second thing, my query execution went from 0 seconds to 17 seconds. 17 seconds. Okay, and now, as I told you, I am changing the compatibility level to 120, which is 2014. Okay, so let's see what happens. And now I am executing the same query in seconds, 0 seconds again, back to 0 seconds. So why on 2012 it is running for 17 seconds, and from 2014 to 2022 it is running only with 0 seconds. If you want, I can show you that part as well. I'm just changing to 2016. Okay, and executing the query again, 0 seconds. It works the same for 2017 as well, 2019 as well, 2022 as well. So right from 2014 to 2022, this query is running in 0 seconds. Whereas if I switch this to 2012, it is taking 17 seconds, as you can clearly see. So this is what happens, guys. In real time, when you perform any migration, all of a sudden, some queries will perform burstly and some queries will run super fastly. You don't know the reason behind it, and you don't know from where to start. So that is where I'm projecting my performance tuning classes. So I'll try to give my best on this. Trust me. So it is 15 seconds now, right? 15 to 17 seconds on an average. So what should we do? And what is the reason for the difference of, what can I say, times when it comes to execution? What do you think? What is the main reason?
So, Vamsi, something to do with cardinality estimation, I guess.
Yeah, for this query, this is with respect to cardinality estimator for sure. Because from 2014, the cardinality estimator got changed. Okay, so remember, again, I have seen few questions in my group about cardinality estimator. Will it get changed for every version? No, that is not the case. So I officially, it's just two cardinality estimators. Right from SQL Server, I can say 7.0 till 2012, we had one cardinality estimator. And from 2014, the cardinality estimator got changed. That is the reason from 2014 to 2022, you are seeing the execution of the query in 0 seconds. Whereas in 2012, and even if I switch this to 2008, it is taking 15 to 17 seconds. So that is the change in the algorithms with respect to statistics. That is cardinality estimator. Okay, so that is the reason for this query to run for longer duration on the older compatibility level, and on the newer compatibility level, it is running fastly. So is there a way that I can write this query so that it runs same across all the versions, irrespective of whether it is 2012 or 2014, 2016, whatever it is? This is query tuning. Okay, the first one is about index tuning. We just created the index what SQL Server has suggested by using the execution plan. And now we got a requirement where we need to ensure that this query runs same across all the versions. Okay, so how to rewrite this query? So rewriting the query, as most of you think, it's not our duty. Yes, I do agree. But there are few companies where they expect the DBAs to help with rewriting the queries. Is there any chance that we can rewrite this query and make it consistent across all the versions? Right? So that is our problem. So main problem here is we are just fetching 4 rows out of the users table, but in reality we are reading 73,000 sorry, 7,39,000 something else, right? As if you can see from the execution plan, we just need is that not this one? Let me switch to 120. Oh, sorry. Okay, and let me execute this. Are you getting the problem, guys?
Yes.
Yeah, thank you. So the main problem here is SQL Server is estimating 7,39,714 rows, but in reality, it's just reading 4 rows. The actual number of rows are just 4, but it is reading too many rows from the users table, which is not required. So if we can tweak on that users part, definitely we can speed this up. So that is how we should consider our execution plan, guys. It's not just I'm blindly teaching. So if you see here, actually it just need 4 rows from the users table. If you see here, okay, let me show you how I'm figuring that out. Just a second. Okay, so let me get this where class, and I will show you in a different window. Select start from users, where users plus reputation greater than 10,000. So I'm just taking the table and trying to see how many rows are there. Okay, just 4 rows. So these are the 4 rows what I need. That is the reason even my execution plan is showing 4 rows. But we are getting 30% of it. So I told you from where I'm getting the 30%. Because if you use any functions like greater than, less than, not just functions, even the greater than, less than, those kind of operators inside your where class, by default, SQL Server would estimate 30% of the rows. That is the nature of SQL Server. You can't skip that part. Okay. So now, in my case, it is working slowly on 2012, whereas it is working fine on all versions of SQL, like from 2014 to 2022. So I need to rewrite this query. So if I can bring only 4 rows from the users table, definitely it would be faster, right? So what should I do so that I can get only 4 rows from the users table instead of this 30% of the rows? So that I need to rewrite my query. How to rewrite the query? Most of you, I know you are not familiar with query tuning, so I don't touch this part, but I'm just giving you hints. Okay, so I just worked on this. So what I'm doing, I will show you. A small technique, guys. This works wonderfully well in your real time. I've seen so many cases where just by rewriting a few queries, the expectations, I mean, the query execution plan, I can bring that down from minutes to seconds. Okay, in this case, what I'm doing. So what I'm doing is, I'm just creating a temporary table. Of course, that is not there. So I'm just trying to fetch the information of users table into that temporary table. If you see, my where clause is on reputation plus views, right? Let me go to the top. So I need reputation and views. So this is the column from where SQL Server is retrieving 4 rows. But unfortunately, it is estimating 30% of the rows because of the plus condition or some function what we have written inside the where class. So to break that up, what I am doing is I am fetching that information into a temporary table. It's just a temporary table, and I'm writing the same class, no difference whatsoever. And I'm fetching the display name and users.id. So what is needed here in the top, on the top from the users table, I need display name and users ID. So the same thing I'm pulling into a temporary table. Okay, so I'm pulling this. See, if you see now, 4 rows are there into the temporary table. Now I'm joining that to the post table. Same thing, no difference. No difference. We are just pulling that information into a temporary table. And now the execution plan is 0 seconds. That's fine. Let's change this to 2012 because on 2012, that query was executing for 15 seconds. Okay, I'm changing that to 2012 as you can see. And now I'm running this query. Same query with just a bit of query tuning. Okay, let me drop this and let me run this. Boom, 0 seconds. This is what we should do in real time. Okay, bit of index tuning and bit of query tuning, and from where we are getting the values and how to check the stats. So why my query was executing successfully on 0 seconds from 0 seconds from 2014 to 2022? It's because of the new cardinality estimator. But on 2012 or 2008, it was running from 15 to 17 seconds because it is on the older cardinality estimator. Okay, so the query was running for longer duration, and to fine tune that, we just dumped the contents of where class into a temporary table from one of the tables, and then we joined the table to the another table what is being required in the query. That's it. Even on 2012, it's 0 seconds. Now, if you ask me how it works on the latest compatibility levels, doesn't matter. It works consistently across all the versions. Let me do this and I'll show you. So if you can write the queries like this, irrespective of your compatibility level, your queries would run faster. See, 0 seconds. Even if I switch this to 2008 for that matter, no problem. I didn't test this, but I am pretty confident it will work. Yeah, 0 seconds. So that is index tuning, guys. The bottom one is query tuning. Any questions?
Vamshi,
Yeah.
Vamshi, so this is nothing. Actually, yesterday I faced the same type of issue, but still not resolved. But the thing is, I want to in the same line only. For example, D1 is a database, T1 is a table.
Okay. T1 is a database,
Okay.
T1 is a table. So what should I understand?
Okay. No. I'll tell you the scenario. Just I'm explaining the scenario.
Yeah,
T1 is a database, T1 is a table. I used D2, select star from D1.dbo.T1. It is executing file. Okay. Now use D4, select star from D1.dbo.T1. It is executing file. Go to use D6, select star from D1.T1. It is executing. It is not at all execute. If it is executing also, it is giving the result after 8 minutes. That is the incident I got it yesterday night.
Okay.
So I checked the cardinality because the instance is on the same SQL server. All these databases are there. Only on one particular database, it is giving
running
this
on the lower compatibility level. Okay.
Okay. Sorry.
Yeah. So only one database in your case is running on lower compatibility level, whereas the rest of the databases are equivalent to that instance.
No. I checked database parameters of all this compared with other databases. Everything looks fine.
Okay.
But still the query is executing like that only.
I can check that for you. I mean, not now, if I get some time.
No. Can I do a DBCC clean buffer and procedure cache something like that?
It's
It's
not.
a product.
I mean, it's not required. See, what I'm showing might not be applicable in your environments, but I'm just giving you hints like how to approach your problems, right?
Okay. Any idea what could be the
can
reason?
definitely. I mean, just to let you know, one of our guys from our WhatsApp group, he consults me for only performance issues. So I'm helping him. So if that is the case, definitely I can just chip in with your performance issues. I can take that up. No problem. But I need some time. Okay.
Yeah, got it. Any just
I'll show you.
any
I will
ideas
show you from the scratch like how I am doing. In the similar way, you can tune your query. So it's not like I'm just coming in and providing the solution. That's not the case. If I'm doing, I will show you all the steps like how I did, and so that you can follow the same pattern. Okay, let's move this for a second, and let me show you one more important thing, guys. Okay, again on the same basis, like how our newer compatibility level will execute or how it behaves. Okay. So I have one more query here, some reporting query, and you would like to always see that CPU running queries, right? I'll show you now. Just wait for a second. Okay, so I have one query now. Right now we are on, what is the compatibility level? I think I changed that to 2008, I believe. Right? Yeah, 2008. So let me change this to 2016. Okay, which is okay version. Like most of your databases might be on 2016 or 2017, right? So I'm switching that to 2016 and I'm running this query. It's just a select statement where I am aggregating by year and month. Okay. So now let me run this and let me show you the CPU. Okay. CPU is 100%. As you can see, CPU is 100%. And what is the process that is contributing? Obviously, SQL Server. So let me show you again. I will run this query again. So it is taking 17 seconds, guys, because it is taking 17 seconds. Let me run this again and show you the CPU. See, 96, 97. It's from SQL. 99 now. So these queries are nothing but CPU bound queries. It will eat your CPU like anything. It's just a simple database, 50 GB database, what I am running my queries. And see how much time it is taking and how much CPU it is utilizing. Okay, so obviously you will get this kind of issues, right? In your real-time scenarios where you will say CPU high, but you don't know what needs to be done. I'm letting you know the importance of the newer compatibility levels and how it affects. As you can see, it is taking almost, let me run this statistics time on. So you'll get to know a few more things as well. Statistics time on. Okay. So my CPU is running to 100% now. It's driving crazily. And this is just one window. In real time, if you multiple persons runs the same query at one shot, what will be our scenario? Are you getting? In real time, if the same query is being run by multiple sessions from multiple users, just imagine our problem. So on my system with just one query, just from one window, it took 16 seconds for query execution. So this is query execution time, 16 seconds. And if you see the CPU, this is 62 seconds of CPU. 62 seconds of CPU. Okay, means it's a very high CPU bound query. And why I got 62 seconds, that's a different story. And if you see, I have 4 processors. So I have 4 processors. Okay, on each processor, it may have got like 15 seconds. So that is the reason 15 into 4, 60 seconds. 60 seconds of CPU time. Are you getting what I'm saying, guys? Or is it too much?
So, Vamsi, 15 times 4 means, do you think that parallelism is happening kind of thing?
Yeah, obviously. Parallelism
Yes.
is happening. So
Yes.
you can see the parallelism operator here. So this query is going for parallelism. And
Yes.
it took 60 seconds of CPU. And if I run this query, it is taking 100% of CPU time. So I have 4 processors here. Okay. So 62 divided by 4, it is like 15 seconds.
Correct.
Since it went for parallelism. If I stop parallelism, that's a different story. So
Correct.
right now we are on 2016. Right now we are on 2016 and it took 16 seconds of query execution time and 62 seconds of CPU. Okay. Now let me change this to 2019 for a second. Before I change that to 2017, I will explain you what is happening behind the scenes. Okay, let me go with 2017 only first. Okay, 2017. From 2016, we moved this query to 2017. Okay, it went fine. We changed the compatibility level. Let me run this query again. And let me check the CPU. Again, it is 100%, as you can see. SQL Server is the contributor. I'm not creating any indexes. I'm not doing any query tuning here. I'm just showing you a simple query. Okay, again, it took 16 seconds, no change with respect to execution plan and the time. So again, it took 61 seconds of CPU. Now, the beauty of 2019, let me show you. If I change this to 2019, what is happening? And I will explain you just a second before I do. 2019, okay, and let me run this query. Will it change anything? Yes. From 16 seconds, I got my query to 6 seconds. 6 seconds. Okay. There is no change in the execution plan even now. And if I go to my execution times, so it is now 4 CPUs, right? So 6 into 4, 24 seconds of CPU time from 62 seconds of CPU time, I got this to 23 seconds of CPU time, which is wonderful. And from 16 seconds of execution time, I got this to 6 seconds without changing the code and without adding any indexes. So what is that is helping SQL Server to go from 16 seconds to 6 seconds when I change the compatibility level to 2019? Anyone knows this?
CE?
Yeah,
Cardinality
anyone
estimator?
knows? Yeah, cardinality estimator. It's not cardinality estimator because, as I told you, from 2014, it is the same cardinality estimator. It's not the cardinality estimator, okay? Because the previous case is with respect to cardinality estimator, but this time it is not. Yes,
Oh, okay.
as Naveen said, from 2019, okay? But the unfortunate thing, okay, let me show you what happened before I explain. If you, okay, I am getting this. I have monitor at Ireland, but not here. I have these problems. Okay. See the actual execution mode. It is showing batch mode execution. It's not row mode execution. Just for your information, guys, row mode execution was there until 2016. Okay, row mode execution was there. Sorry, batch mode. We don't have batch mode execution until 2016. So this batch mode execution has been introduced from 2017. Okay, I'm repeating. Batch mode execution has been introduced from 2017, but in 2017 it works only for column store indexes, not for traditional our indexes, B-tree indexes. If you have any column store indexes, only for those indexes, batch mode execution will come into picture. That is the reason if I run this query from on 2017 compatibility level also, it took 16 seconds. Once I change from 2017 to 2019, all of a second, from 16 seconds, we got this query to 6 seconds. And from 60 seconds of CPU time, we got this query to 24 seconds of CPU time. Because from 2019, we have this batch mode execution even for regular indexes. I mean to say B-tree indexes, not the column store. That's the beauty of 2019. It's there only from 2019, and it obviously it will be there in 2022 also. So from 2019 it got started. If you want, I'll just show you. I'm switching this to 2022 and I'm running this query. Okay, so it took 6 seconds. Even here it should take 6 seconds, not more than that. 6, yeah, 6, exactly 6. And if you see the query execution times, 24 seconds of CPU and 6 seconds of execution time. So that is the beauty of 2019. So if you know the reason, you will get to feel happy, right? So it is because of batch mode execution. But unfortunate thing is, it's not possible to find out from the execution plan which operators went into the batch mode and which operators went into the row store mode. As you can see, this entire query is with batch mode now, except the last one, the parallelism operator. As you can see, that is going with row store. The rest of the operators are with batch mode. If I change this to 2017 also, let me show you. And you will get to know that row store, and which is used to take 17 seconds. So now it is 2017. And if I execute this, it will run for 16 seconds. And it takes 60 seconds of CPU. And during that entire phase that of 16 seconds, your CPU will be 100% high. 100% high. Okay. So if someone asks how it went faster on 2019, you should be able to answer. Don't just give cardinality estimator compatibility level. That is there. That is okay. I'm not denying that. But try to give your answers in a much better fashion. Now, if you see my index scan, it is going for row mode. It's not batch mode. Okay. So this is called as intelligent query processing. It started from 2017 and many features were enhanced in 2019 and even more features were added in 2022. Okay. So right now, I just try to explain you about batch mode operator and how it helped us from bringing down the query execution time from 16 seconds to 6 seconds without changing anything with respect to query or indexes. With no changes, we got the query from 16 seconds to 6 seconds. Okay, what is the reason? It's because of batch mode operator. Batch mode operator works from 2019 only. Yes, it has been introduced from 2017, but batch mode operator works only for column store indexes on 2017, whereas on 2019, it works for all indexes, irrespective whether it is column store or row store. Okay, so that is the second query. So I have one more demo, but I don't know. I mean, it's 8:30 here. If you are interested, I can teach you the second demo. I mean, third demo, or else I will stop. It's up to you guys.
I think we can proceed, man. I would say let's proceed.
Yeah, how about others?
Yeah, we'll take the opinion. I mean, again, if you
Because
do in the next session, then I think the chances are that we may forget this. So again, I go with the majority.
So I'm fine, Vamsi. You can
okay,
proceed.
okay, fine. So let me. Yeah.
Just one scenario I can explain on. I mean, I'll give one scenario which I faced. It's a long back. I think 1 year ago I have faced it.
Okay.
Same like we have upgraded the SQL version from 2014 to 16. After
14 to
upgrading,
16. Okay.
yes, 14 to 16, and it's an enterprise edition. Whatever, it's the same. After upgrading it, immediately it started application went slow. Even
Okay.
it's not even the one functionality, all the functionalities and everything. Application, it's a very slow. From
Okay.
1 second to it is taking 20 seconds each functional. It means 20 times lesser of that one. Okay.
Okay.
At the time when, as you said, the cardinality estimator is same, and you have shown some examples as well. But at the same time, we have seen the cardinality estimator was the problem during that time. When we
Okay.
changed that compatibility level, we already changed the compatibility level for all after upgrading. So when under the statistics and everything same, when we without changing that compatibility level, we just switched on to the old cardinality estimator. Then it was working fine.
So with respect to your scenario, okay,
Yeah.
so there are many things that we need to understand. Okay, let me show you that part. Just a second. You are able to see my screen, right?
Yeah, I can.
Just hold on for a second.
Because as it is it's a platinum application and very critical to the business. So what we have done is, for time being, that one we have just changed that cardinality estimator to off.
Okay.
It runs to the 2014. When I changed that one in the configuration of the database, it went well. Even that, as you said, that execution plans also works well.
Okay, just
But
a
if
second.
it is the same, I don't know why that much difference.
Yeah, I will show you why. I mean, for your question, I am preparing demos. Okay, so now I am showing the other way. So when I'm switching to higher versions, it is working fine. So my demos on the next upcoming classes will be on the higher version. It sucks, but on lower versions it works fine. Okay, you need to understand the the internals of it. Okay, let me show you, because I'm reading a lot of things to show this up. It's not that I am doing on the fly. So for I'm getting a gap of almost
we are
a
not
week.
saying you are
No,
doing on
I'm
the
saying
fly.
like it is taking a lot of time than what I expected. So let me show you about that part. A second. We're almost there. Yeah. So these 4 classes we need to understand. These are the changes with respect to cardinality estimator. So if I show this up, no one will be able to understand. If I say there is uniformity, independence, containment, and inclusion, you will not be able to understand, because these are all so much internals that we need to deep dive. So that's what I'm coming. That's what I'm doing. I'm understanding the complexity and I'm coming with simple examples. Okay. So I'm reading this out. So as you can see from SQL Server 7.0 and still SQL Server 2012, it's the same cardinality estimator, and it got changed from 2014. So see, this is all about 120. 120 is nothing but 2014. Okay. So and why what is the reason? So we need to understand those 4 parts, like independence, those whatever the mentioned, uniformity, containment, inclusion. So these are the reasons. So for each one of them, we need to prepare a demo. I mean, I will definitely I'm on it. So I'm preparing demos for each one of them, so that you will come to know like why it is working fine on few versions, why not on other versions. So you need to understand those 4 things. It's a bit complicated, but yeah, we'll try to manage that.
Okay, yeah. Thanks.
Okay.
Yeah, sure.
There's one more demo left, right? Okay. This is about table valued functions. Okay, table valued functions. And without any change, it will work fine. So just by changing the compatibility level again. Okay. So when it comes to functions, we have two types of functions. Let me show you. Tables, programmability, functions. So as you can see, there are two things. Aggregate functions, system functions, you can leave them out. We have basically two types, table valued functions and scalar valued functions. Okay. So inside the table valued functions, again, we have something called as inline table valued function and multi-statement table valued function. For you who are not aware of what are table valued functions and what are scalar functions, and this topic might be a bit complicated, but I will take one more demo where I will show you what is inline table value function with simple demos and what is multi-statement table value function and what is the other one, like the scalar functions. We'll discuss about that later. But I'm just showing you as this part of continuation. I mean, the same compatibility level, how it affects. So I'm just pulling up with a simple demo. Okay, imagine you had functions in your environment. Okay, in your case, you just imagine you are a consultant and you just checked your DB and this is your statement. So let me show you the query. Okay, this is a simple query they are running. This is on AdventureWorks. Okay, so let me check the compatibility level first. Options. Okay, it is on 2008. Okay, for that purpose, let me bring this to 2012. Even on 2012, it sucks, no problem. But let me show you. Okay, so someone asked me the doubt, right? By changing back to 2014, it worked fine. Not on 2016. So for you, it's the right example. Let me show you. I think, okay, let me run this. AdventureWorks, I think it's just 2 GB database or 1 GB database. I just expanded the tables, few tables. So that's the reason I got 1 GB or 1.5. So even for 1.5 database, 1.5 GB of database, it is taking almost 15, 16 seconds, 17 seconds. A simple query. Okay. So I will show you where it went wrong and what needs to be done. If my headset worked fine, it would have been very nice, but unfortunately, that is not the case. Any questions, guys? How you are feeling? Any feedback that I'll try to improve myself with PTs, I mean, performance tuning?
No, this is perfect, man. For me, this is perfect.
Okay.
Yeah, we are getting a lot of information.
Good for me. Okay. Oh,
Good
see,
on say. Give it up.
Because that batch mode, we don't know, even still we are using 2019. But at
yeah,
least we
there
are
are multiple things
yeah.
lined up, man, with respect to performance tuning. You will get to know so many things. I promise you on that part.
Yeah.
Okay, a simple query of 1 GB database, it took 1 minute, 2 seconds. Okay, 1 minute, 2 seconds. So where is the problem and what needs to be done? Okay, so this is the query. In real time also, definitely you will see scalar valued functions are, I mean to say scalar or inline table valued or multi-statement table valued functions. So you need to understand the differences between all three. So as I said, I will prepare a demo only on 3 of them. And you will get to know the differences and what are the things that you need to be very aware of those 3 functions. So let's go to the problem. So I got the result, that is fine. So if you just turn this on, just for your information, set statistics profile on, just like IO and time on, you will get to know this, you will get this chart. Like for each operator, what are the estimated number of rows? Same thing, whatever what you are seeing in the execution plan, it is now coming up in results. That's the only difference. This is there on Oracle as well, I believe so. Not the same thing, but like this, something like this. And if you see here, for every operator, the estimated number of rows are 1. Only 1. Okay, but in reality, the number of rows what we fetched is very different. These are the number of rows what we fetched. But estimated number of rows are 1. Okay, for some reason, it is just expecting 1 row from the all operators. So there is the problem. So there is a mismatch of estimated number of rows and actual number of rows. So definitely statistics problem. That's what you will conclude. On the fly, it's the very next moment you will say statistics problem. Don't blame statistics all the time. It's not the statistics that is the problem. You need to understand there is so much behind the scenes that is affecting your cardinality estimator. It's not statistics. Maybe most of your times you think that updating the statistics might help your problem. That is not the case with all your queries, guys. That is what you should understand. That is what I am focusing on. It's not the problem with statistics. Don't blame statistics all the time. Stop giving that answer. Okay, so here, if you want, I can show you the DBCC show statistics output. Definitely they're up to date. So don't bring that point into picture. But still I am getting, SQL Server is estimating just one row. Okay, I will let you know why it is. So before that, I would like to change this compatibility level to 2016 as well. Let me jump to 2016 from 2012. 2016. Okay, it will be almost same, no difference. So let me run this again. Okay, why do you think SQL Server has estimated just one row from the all the operators inside the execution time? Why just one row? When in reality we are pulling almost some billions of rows. It's a million, right? Millions of rows. Where is the problem? I told you already, it's not the problem with statistics.
It's about compatibility or like some
Compatibility now from 2012 we changed that to 2016, so we are on newer cardinality estimator. As I told you, from 2014 we got that new cardinality estimator. So right now we are on new cardinality estimator, and still it is taking almost same time. So it is 1 minute 2 seconds what it took for 2012. I think almost it takes the same time. Okay, 50 seconds. It is still executing. It will take 1 minute 2 seconds, close to that. So it's not the problem with cardinality estimator. There is something else that is stopping SQL Server.
It's about SQL, architecture. See, like the query execution plan have a different in 2014. It will be different in 2016. That might be the reason.
No. So I will tell you. So you will get to know. So
Is
understanding the
the
internals is the most important thing, guys. So that is where you should focus on. Okay. Coming back to our output. So now, if you see the estimated number of rows, for all the rows, we got, of course, leaving out the 1 and 1 about the last bottom ones, leave out that. And for all the other things, we got 100 rows all of a second. Okay, 100 rows. Previously, in 2012, it estimated just one row, but now it is estimating 100 rows. 100 rows from all the operators. And in reality, we are doing again some millions of rows. If you see some millions of rows. So from where I got that 100, just like my previous question, where I got that number 739714, some number was there, right? In a similar fashion, SQL Server is just estimating 100 rows. Okay, so I will tell you the reason before I switch this to 2017 and how it works. Okay, so this is the problem with multi-statement table valued function, guys. So if you have any multi-statement table valued functions until 2012 or 2014, it will expect only one row. Only one row. Doesn't matter how many rows you are pulling, but SQL Server always thinks that you are just pulling up one row. But from 2017, from 2016, it got changed. So they expected to change this behavior. And from 2016, 2017, we will get 100 rows. From table variables, it will expect 100 rows. And from 2019, it got changed completely. And now you will get the expected rows. So that is the reason behind your queries, like why it is running slowly. So if someone asks, it is not the compatibility level or cardinality estimator. It's because of table variables. Table variables inside the multi-statement table value functions, or even if you write the manual table variables, it's the story behind that. So if you have table variables, always keep an eye, because until 2012, it's just one row. From 2014, I think it is 100. 2014 and 2016, it is 100 rows. And from 2017 or 2019, it got changed. And now you will come to know like the exact number of rows that is being pulled out from your functions. So this is something by name, they call it as deferred compilation. I don't want to go up to that level. So I just wanted to ensure that you are able to understand with simple terms. Okay, now we are on to 2019. So let's see how much time will it take for its completion. So you should understand, see, 11 seconds. From 1 minute, 2 seconds, we got it to 11 seconds. Did I change anything? I didn't change anything. It's just the compatible level what I changed. The cardinality estimator remains the same. There is no problem with cardinality estimator, but on the newer versions of SQL Server, the way estimates are coming up is completely different. So for table variables, now if I go to my estimated number of rows, and if you see the problem area, we got only 100 rows over there. Now, let me show you the important one, this one, the table valued function. So now it is expecting the exact number of rows, some millions of rows. SQL Server now knows that, okay, it is not 1 row or 100 rows from the table that is being pulled from this table variable. We have, what is this number? 680, 2000, 52,000, 4.8 million. 4.8 million rows are there. So now it knows the exact number of rows that it is being pulled from table value functions. That is why without changing any code, my SQL Server is working much better on 2019 or 2017. From even on 2017, this will work, I believe. So this is the problem with multi-statement table valued functions. If you have any table variables, it sucks. It sucks on the older versions, but not on newer versions. Of course, still we have problem with table valued functions. I will explain the problems later, but this is just an introduction. Okay, again, don't say it's CE or CL for all the things. You have to understand why it is behaving differently on each versions. You have to understand the reasons behind that. Oh God, I'm done. Any questions?
Vamsi, I
I
have
will
a
share the
suggestion.
demos also. You don't need to worry. All the scripts I will share in my group, like you know that folder, right? So I'll share over there. You can practice
Vamsi, I
those
have a
things.
suggestion, man. From next session onwards, I mean, it's your call again. After this session, it's better you give 10 minutes or something so that after the session, I'm saying that way people can ask questions, not even related to the current session, but apart from that, the interview questions and all that stuff.
No problem.
Okay?
Yeah. So there are
We
three
never
things
had SQL
what we
Server.
discussed. Yeah, sorry. I'm sorry to break you up. I just wanted to conclude.
Vamsi, you go ahead. I'll ask after you're done. Please go ahead.
Okay. So it's just 3 topics what we discussed. One is CL, the other one is CE in simple terms, but in reality, I've shown you the real examples like how my query got affected with older compatibility level, and after changing that, how it went fine, and how we need to rewrite our queries like query tuning so that it remains same across all the versions. So that is the first demo. Second demo, it's with batch mode execution. You need to understand from when batch mode execution came into picture and how it helps the SQL Server queries. And third thing, it's about table variables, or I can say multi-statement table valued functions, and how it expected just 1 row and 100 rows and the right number of rows. So these are the 3 demos what we went through. And the upcoming sessions will be something on the similar lines where you will see all the real world practical examples. Okay. Yeah, now your question. Go ahead.
Okay. I had to interview someone yesterday. I mean, I'm not capable, but team members, they pulled me. So I asked, like, give me introduction and what versions you worked on. So I'm pretty much positive that SQL 2021 never existed, right? It was like 16, 17, 19, and 22, right?
That's it.
Yeah, he said I worked on SQL 2021. So I said, as of I know, it was 17, 19, and 22. So
yeah,
then
he
I
came
said,
from Mars, so obviously he might have worked in Mars for sure.
So I said he was trying to fool me. So I thought maybe I can just check. And luckily, I saw your session invitation this morning, so I thought I can ask you. So, yeah.
Yeah, he's from different planet if that is the case.
That's what I was confused, and I don't know, maybe I missed something, but yeah.
No. See, actually, Microsoft had a plan. I will let you know. Like, I came to know from one of my friends. Like, they told me that SQL Server. I mean, Microsoft had a plan where they wanted to release different version for each year. But there are so many people who said it is not possible to test for each and every version. It's highly impossible, and there are many vendor applications, and they can't test. So they decided not to go with such approach. So they decided to go with again the if you see 2016 we got one model, right? 2014 we got one version. 2016 again in the matter of 2 years we got one more thing. 2017 again we got. So they had their plans 2016, 2017, and the thought of going with 2018, but they stopped it, and again they went with 2019. but later realize there are so many things. There are so many things that are they are building up. So it's not possible to go ahead with each and every year. So that is one thing.
Yes.
And there are so many bugs they are fixing it up. So it's not possible to fix each version with few cumulative updates. So that's why they stopped that idea. And after 2019, we got 2022.
Correct. That makes sense.
Yeah. Any questions with today's demo? For few people, I do agree that it may be a bit high, on a higher side, but this is how it will be there in your real-time environment, guys. So I can't help you on that part. You need to upgrade yourselves. If you feel confident with respect to query tuning and index tuning, you will feel much, much, much safer with your positions. Okay, so I'm taking this now. Yeah, any question?
How does SQL Server determine how many rows will be in a batch mode?
How SQL Server determines?
How many rows will be in a batch mode? In a batch mode, I think SQL Server executes in a number of rows in a batch rather than single rows as row mode. So how does the SQL Server engine determine how many rows will be in a batch mode?
Okay. How many rows do I need to pull from each batch? Right? Is that the question? Batch, how many rows it pulls out from one batch execution? Is that the case?
Yes.
This is a very difficult question. I need to go through the batch mode execution, but I didn't go through that yet. This is a new topic, right? So first we need to understand column store indexes for this to answer. So without knowing much about column store indexes, I cannot answer like why it is going up with that value 4852 something is there, right? So I will figure out that. I'll take some time, but thanks for your question. I'll take that up.
Thanks.
Yeah. Okay, guys. So I'm stopping. And if you have any questions, you can ping me on WhatsApp. I'm feeling thirsty, so I will move on.
So God bless you all, man. Thank you once again.
Yeah.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.
Thanks all.
Thank you.
Thank you.